Welcome again students to the lecture of number theory. We were discussing about properties of bracket function. So the next property we are going to prove is greatest integer x plus greatest integer of minus x. It is equal to 0 when x is an integer and minus 1 otherwise. So first we take the case when x is integer. When x is an integer, then its greatest integer value comes out to be same as x, and greatest integer of minus x is minus x. Therefore, their sum greatest integer x plus greatest integer of minus x, it is x minus x, that is same. Our first condition is proved. Again, otherwise that means when x is a real number. When x is a real number, we know x can be written as greatest integer x plus r. R is the fractional part which lies between 0 and 1. So therefore minus x can be written as minus of greatest integer of x minus r. Now what is its fraction? Greatest integer. Greatest integer of minus x is greatest integer of greatest integer x minus r. Now what about minus r? If r is any fractional part, say it is some decimal number. For example, we take minus of 0.4. What is its greatest integer? We plot it on line. It is 0. It is minus 1. And minus 0.4 lies somewhere here 0.4. Minus 0.4. So its greatest integer is the left hand side number which is minus 1. So its greatest integer is minus 1. So it comes out to be minus of greatest integer x minus 1. So taking the sum greatest integer x plus greatest integer of minus x, it is greatest integer of x minus greatest integer x minus 1. Its value is minus greatest integer x minus 1. So it is minus of 1. Our second part is proved. The next result we are going to prove is greatest integer of x minus y is less than equal to greatest integer x minus greatest integer y is less than equal to greatest integer of x minus y plus 1. So now we are having two real numbers, x and y are real numbers. So therefore x can be written as greatest integer x plus its fractional part r1 and y greatest integer y plus r2. r1 and r2, these conditions are 0 less than equal to r1 less than 1, 0 less than equal to r2 less than 1. We are to take it their difference x minus y, that is greatest integer x plus r1 minus greatest integer y minus r2, that is greatest integer x minus greatest integer y plus r1 minus r2. Now what is the value of r1 minus r2? Now r1 minus r2 is definitely less than r1 because r2 is a number lying between 0 to 1. When we subtract it from r1, then it is less than r1 and r1 is less than 1. So it is less than 1. Again r2 is less than 1. So therefore minus of r2 is greater than minus of 1. Adding r1 both side, so it is greater than r1 minus 1 and r1 it is greater than equal to 0. So greater than equal to 0 minus 1, that is r1 minus r2 is greater than minus 1. So its condition is minus 1 less than r1 minus r2 is less than 1. We have proved these two conditions. We break it in two parts. r1 minus r2 is less than 0, it is greater than minus 1, and r1 minus r2 less than 1 greater than equal to 0. So when it lies between minus 1 to 0, then what is its greatest integer? r1 minus r2 greatest integer, as we have used in our previous part, it is minus r1 minus r2, it is minus 1, sorry. it is a number lies between minus 1 and 0, then its greatest integer is minus 1. It is minus 1. And what about r1 minus r2 when lies between 0 and 1? It is equal to 0. Its greatest integer is 0 because it is less than 1. It lies between 0 to 1. See, its greatest integer is 0. And here it is minus 1 to 0. It lies between this part. So its greatest integer is left part, that is minus 1. So using these two conditions, we put it here. What is the value of greatest integer of x minus y? Greatest integer of x minus y, either it is x, greatest integer x minus greatest integer y minus 1. Taking the first value of r1 minus r2 greatest integer, that is minus 1. Or it is greatest integer y minus y plus 0. The value is 0. So we are having two values, minus greatest integer x minus greatest integer y minus 1, or greatest integer x minus greatest integer y. So the bigger one is this. So greatest integer x minus y is less than equal to greatest integer x minus greatest integer y. Also, the lesser one is greatest integer x minus greatest integer y minus 1. Therefore, it is greater than equal to greatest integer x minus greatest integer y minus 1. Also, we can prove this condition in a way. Greatest integer of x can be written as greatest integer of x minus y plus y. Now, we have proved that greatest integer of x plus y is less than equal to greatest integer x plus greatest integer y plus 1. So therefore we use this condition here. It is less than equal to greatest integer x minus y plus greatest integer y plus 1. So it is greatest integer x. Taking greatest integer y to left hand side, greatest integer x minus greatest integer y is less than equal to greatest integer x minus y plus 1. This is to be proved. Greatest integer x minus greatest integer y is less than equal to greatest integer x minus y plus 1. And the another part, greatest integer x minus y is less than equal to greatest integer x minus greatest integer y. Combining these two, we get the total result. Also, this result can be derived from here. Greatest integer x minus greatest integer y is less than equal to greatest integer x minus y plus 1, taking minus 1 to the right hand side. So this result is proved. The next result we are going to prove is, if x is a real number and n is an integer, then greatest integer of greatest integer x by n is same as greatest integer x by n. Now x is a real number, so therefore x can be written as greatest integer x plus its fractional part, we take it as s. 0 less than equal to s less than 1. Again we are having two numbers x and n, where greatest integer x and greatest integer n both are integers. If they are integers, we can use the division algorithm. What is division algorithm? Division algorithm says, when we are having two integers, then we can divide them. We can divide any one of them by the another. When we divide, we get a quotient and the integer. That means there exist two integers q and r belongs to z, such that greatest integer x can be written as nq plus r. We are having two numbers. We can divide greatest integer x by n. We get the quotient q and the remainder r. So now we use this condition, greatest integer of x by n. That is, we prove the right hand side. Greatest integer of x by n. We have used x is equal to greatest integer x plus s. X is equal to greatest integer x plus s upon n. And the value of greatest integer x is nq plus r. So its value is n q plus r plus s upon n. When we divide, cancelling the n from first part, it is q plus r plus s upon n. Now what is the value of r plus s? The condition for r and s is s lies between 0 and 1. 0 less than equal to s less than 1. The condition of r is left here. We write it here. R is less than n greater than equal to 0. Remainder is always less than the divisor. Here divisor is n. So r is less than n and it is greater than equal to 0. So we are having the condition r less than n greater than equal to 0. So since r is strictly less than n, so therefore r is less than equal to n minus 1 because it is an integer. So we can write it as r is less than equal to n minus 1. And s is less than 1. We add them. R plus s is less than n minus 1 plus 1. That is r plus s is less than n. That means r plus s by n is less than 1. So it is a decimal number. That means it is the fractional part. So what is the integer in it? Its integer is q. Also greatest integer x upon n. Its greatest integer x. The value we have written here is nq plus r. nq plus r upon n. That is q plus r upon n. And r is strictly less than n. What this implies? R upon n is strictly less than 1. That is, it is the fractional part. It is the decimal number. It is greater than 0. So therefore, its value is q. So both the numbers are same. So therefore, greatest integer x by n is same as greatest integer x by n. Thank you.